Okay, so the first thing I want to talk about today is how we can rewrite a log as an exponential, or how to rewrite an exponential expression as a log expression. The whole purpose of this is to be able to take out variables from various places and rearrange them so that they're better suited for whatever equation you're trying to solve. So in this case, we're looking at a log and we want to rewrite it as an exponential expression. The way I think of this is the base, as we call it, both the base of the log and the base of the exponential. In the log case, that's the number, the little subscript for the log. So that's called a base. If I had this written as an exponential type of an expression, the base is what we call the number being raised to a power. So they're both the same term because they both represent the same exact thing in both problems. They're just rewritten different ways. So the base is always going to stay the same. And then if you remember that logs and exponentials are inverses, the output from the log, what it's equal to, becomes the input in the exponential function. So it's that number that you're raising as a power. The input from the log becomes the output, or what the exponential is equal to. So that's how I usually rewrite these, is by saying the base is always the same, it represents the exact same thing, and then the inputs and outputs switch places between logs and exponentials. So you can rewrite in either direction. So what I wanted to do was a couple of practices. You have a couple of problems on the test review, one where we're switching from logs to exponents and one where we're switching the other way around. This is also very helpful, almost needed, in order to solve all of the equations related to logs and exponentials. Okay, so I'm going to write one that's similar to what's on the test review, but not exactly. So that would be 2 times 2 is 4. Times 2, 6, to the 6, to the third is 8, squared, yep, I think that's right. Let's hope it's right. Okay, so if we write this as an exponential, then you want to first check for the base of the log. If there isn't anything written there, then the base is 10. If you're looking at a natural log and nothing's written there, then that's a base of e. Otherwise, it has to be written if it's anything other than that. So this one has a base of 2, which means when I go to rewrite it as an exponential, my 2 is going to be the number raised to a power. Then I look at my input, the number that I'm actually taking the log of, and the output, which is the number the log is equal to, and those two are going to switch places. The input for the exponential is the exponent, and the output for the exponential is what that's equal to, which in this case was 64. So we just switch the 6 and the 64, and the base otherwise stays the same. Now this is very helpful when we're actually solving equations, because if you ever have a number trapped inside the log, so let's say this is a variable, and we need to get it out of the log. If you look at your exponential version, that number is by itself. So if that was something like an x, and we needed to know what x was, we could always rewrite it as an exponential, and now x is already by itself, which is our key. That's what we're trying to do. So it can be helpful to do that. Let's say you were going the other way around, though. What if I had an exponential that had an unknown variable in the power? And I don't know how to get that out. I don't have a way to rewrite it so that that y is no longer in the power. If I rewrote it as a log, that y would be by itself, so I would be able to solve for it. And that's the key. That's the reason why we're switching back and forth. And that's the most important thing to remember when you're solving equations. The only reason you switch between the two versions is if you can't get that variable that you're solving for out of the problem and it's in some place that you can't access, so like inside of a log or inside of a power. If you switch between forms, then you have that variable by itself in either case, and you can put everything else into the calculator. So I think I'm going to stop for there, and then in the next couple of videos I'll do some equations to show you how we use these, but this is definitely key to be able to solve any of these problems.